Hello and welcome to Hadoop Exam Learning Resources. In this session, we are going to cover Apache Flume components and its configuration in depth. So we'll first start with the simple Twitter feed configuration, how Twitter feeds can be pushed into the HDFS sync, and then we go to the source sync and channel configuration in depth, and after that we will see the how HDFS sync works, how files are uh, stored in the HDFS sync using the Flume. Then we'll see little bit on compression codec, and later on we will go on to the types of channels. There are two types of channels, durable and non-durable. One is memory based, another is file based channel. So we'll see the benefit of the each of this channel, and later on we will little bit see on the interceptors, and at the end we'll look into the channel selectors and sync processor. So let's start with the first with the simple Twitter feed configuration. Okay, so let me clean out this screen. Okay, so before that let me change to the screen. So this is the Twitter feed configuration, which we will go line by line and see the different configuration meaning and how it is useful and when we should do this. So let's go to the uh, let me draw the diagram and then we will go to the this configuration. So first of all, as from our previous session, you have remember, like, there is a source which reads your feed, correct? So suppose this is Twitter feed, which is continuously producing the different type of tweets that would be read by the source. Then from the source it goes to the channel. You must have remembered from the previous session. Then from the channel to it goes to the sink. This is the Flume generally works the way, and from sink to the HDFS. So this is our Hadoop framework. Okay, so this is Hadoop framework. So HDFS is here. So this way data goes, and is remember this all three components work in another process that is called agent. So for each Flume configuration, for feed configuration, you need to have at least one agent. Okay, so this is the source which read from here, this is channel, sync, and all these three processes runs under the one daemon that is called agent, and this sync will push the data to the HDFS. So let's say this is your source, so you can give it name as a Twitter. This is name of the source because you are reading from the Twitter, so that's you can give the name. Okay, let's first give the name to the agent. So I'll give this, my agent name is Twitter agent something. Then this is source, and similarly I would want to give name to the channel. Let's keep it channel right now. We'll see what we have configured. And the type of the channel, I would say this channel is memory type. We will see the meaning of this. So this I can say it's a memory type channel, and this is sync because my data is being sent to the HDFS, so I can give the name to the sync HDFS. However, this is your choice. You can give Twitter HDFS name or something like that. So this is the configuration which we will see. The same needs to be configured into the Flume configuration file. So let's say you have, so this is our configuration file. We have given name to the our agent. So this is the name of the agent. You can see a Twitter agent. And what is the source name? This is sources, correct? So you could have multiple sources as well. So we have given Twitter as a name. Okay, Twitter agent also has a one channel, correct? So you can see here, this is the channel. So this is sources. We have given name as a Twitter. This is the channel name. So this memory mem channel is the name of the channel. Okay, so we have given. Then similarly sync. What is the sync? This is HDFS. So we have given the name as a sync HDFS. Okay, so this is the name we have defined. Sources is called Twitter, channel is called mem channel, sync would be called HDFS. Now let's move to the next configuration. This is the agent. This agent has one sources and source's name is Twitter, and what type of this source. So there has to have, you have one implementation of this class. This is like, I would tell you, this is the Java class or default type which is already provided by the Apache Flume. So let's assume here Cloudera implemented one Twitter source class to read from your data from your Twitter. So this is this class you have to define. So this is the Java class which you are going to use it. Okay, so this is the configuration regarding this. So let's, before moving into in depth on this configuration, let me move to the another diagram. Sorry, so regarding source, okay, first let's discuss regarding source as we were discussing Java class. So many sources come with flow by default. Like example, let me give you the tail source. So if you want to run a one log file is keep being written into the Unix box, and you tell it, so it continuously prints some lines, correct? So this can be used as a tail source. Now next is exact source. So this exact source is any command you can run it and fetch the file output, and that can become your source feed for the your source, correct? So suppose, let's example, it's my commercial website. Okay, this is my website which I will continuously push my whatever is being sold to one file only, not database, let's say. Okay, okay, one file, and using this file I would fire a command. Let's say any command, like I would say tail hyphen f and my sales.log file. This command I wanted to fire, and whatever output of this command, and I continuously fire this command periodically, correct? Just like in every 30 seconds I will keep firing this command, and whatever is the output every 30 seconds, 3 seconds or 1 second would be feed to the source. So that's why this is called exact is one type of source, another is the tail source. So tail source is now not available, that has been removed because of some problems are there. You can read detail regarding this why it has been removed. So in place of that, there's the exact is introduced, and using the exact you can provide the tail command to use it as a feed for your source, right? So this is the reason. However, this is the default sources are provided. There are many others you can find it regarding that. Other than that, there is another class actually. If you want to implement your own custom, so there is a org.apache.flume.source, and there's an abstract source. So this is the abstract class, correct? This abstract source is provided by the Apache Flume itself, and anybody who wants to implement their custom implementation, like how to read the data from various places. So in this example from here, we have implemented, or Cloudera implemented Twitter source. So how they have created Twitter source? They have just extended this class and implemented to read the Twitter source from the Twitter API using Twitter API, which is provided by the Twitter itself to read from their Twitter feeds continuously being produced, which using this API you can read it, correct? So once you read from API, so there is a one Twitter source which uses this API and read it. So you have to configure that Twitter source in configuration file if you want to read the Twitter source. So here for the example we have seen like Twitter source, that this class has already been implemented by the Cloudera for your sample, so you can use it. So that is the example of what I said, source. Okay, so this is Twitter source. Now all this event from the source needs to be returned to the channel. Now next we are done with the source, we have some configuration, we are done with this regarding the source, then that has to be moved to the from source to the channel, correct? So what else configuration we have? Let's move to our configuration. Okay, what it says. Okay, this is now next. What is the source? So this is agent to source. Source's name is uh, Twitter, correct? This is the name of the source. And what channel name? Channels is mem channel is would be used by. So this source will send data to the mem channel. So this will be my mem channel, memory channel. Let's like the name we have. Other than that, the Twitter source needs this full properties. So anybody cannot directly read data from the Twitter using Twitter API. They need authentication and authorization, proper user ID and token to access it. So whenever you try to experiment with the Twitter Flume's Twitter source, so I suggest you create dummy account, because using your regular account can harm your Twitter mm, or credibility. So you first create a dummy account for your developer and then use it. So it will generate this four values: consumer key, consumer secret, access token, and access token secret. So we will not go in detail for this, because later on we will see how you can get it from the Twitter. However, you go to the Twitter dev account and you can create it and you can get all four values. Now that is the keywords. Next is the keywords. So we are not going to read all the tweets which are provided by the Twitter API. We are going to read, because there are lot number of tweets being published, and if you want to read all this, so no use. You can filter it out. So these keywords are there which tells you what the Twitter. Please give us all the tweets which has these are the keywords in the Twitters. So this is regarding your Twitter source configuration. So this is source part. Now let's move to the next is the channel, correct? So channel is, sorry, so before, like, channels already defined. Now let's move to the sink. Okay, so we have defined the channel, which channel would be used. So this is mem channel is the name. Sink also read data from the mem channel. Now what type of my sink is HDFS, correct? So the data from channel to sink and sink to it will go to the HDFS cluster, correct? So the type of this sink would be the HDFS. So it is internal implementation of the Flume, which I easily understand by based on this parameter what classes I have to internally use if I have configured HDFS. Then path. This path will be like your HDFS URL. So in this directory, Flume user Flume tweets and with the year, month and date and hour. So every early at one directory would be created and their data would be transferred. So let's and this data would be streamed. So binary data would go as a binary stream, it would go, but stored as a text. So we will see later on about this and many other things. Okay, so this is regarding sync. So before that we move into this so let's go a little bit in depth with the sink. Okay, so what exactly is sink and what is the different thing. Our this session is little bit theoretical, but we need to understand in depth about this actually, so we can implement this. Okay, so sink and sink processor. So our next topic is sink and sink processor. What are this? We'll discuss regarding. So sink we have already sink. So there are various kind of sink already bundled with the Flume default implementation. Like this is one of the example is HDFS. Another is other sinks you can download if you need data. Like suppose you are reading data from the or if you want to write data into the MongoDB instead of HDFS, if you can write in a MongoDB itself, you can write same data into the Cassandra. You can write to the another database times 10 database or something. So this kind of the available sinks are available which you can use, or even these are not enough for your requirement, then you can create your own using org.apache.flume.sink.abstract sink. there is a class, you extend it and you can implement behavior which is you need it. So this is the way you can extend it, the sync class. So now we have already discussed like HDFS, we will use it for the HDFS implementation, and the path we can provide, the path can be HDFS URL, or if you don't provide the HDFS URL, you can provide the absolute path as like this user Flume or whatever, it's your directory, you can provide it. Then you can also provide the relative path, etc. So this way you can define the your what do you say, sync path and other resources. Now there is another configuration that is file rotation related. What that means, file rotation? File rotation means by default Flume will rotate actively written file in every 30 seconds. So whatever the files you are keep writing correct into the file, the sync keep writing, so after 30 seconds it will create another file. So every 30 seconds it will, because it is assumed it's real-time data streaming, so huge data being written to the each file, so each file would be created in every 30 seconds. However, this value you can change it using the role interval. Some configuration is there to change this value to the, some 60 or something else. Let's see if we have this configuration over here. It's role count base. Okay, this is count based configuration is there. Another is you can have role interval, similarly role interval, so either of one you can use it. So here role count means after 1 lakh lines, or sorry 10,000 lines, this will create a new file. So it will create every time 10,000 lines are inserted, then this file would be created. So now let's move to the next configuration is compression codec. Why compression codec? Actually what happens in HDFS, you can compress the file once it is written, because this file could become big and big and you don't want to occupy the space too much. So while writing to the HDFS, you can compress this file to the smaller size, and for the compression there are various codec is available, correct? So codec is compression and decompression. So you can provide agent dot sync dot, suppose your what do you say source sync name is whatever, you can give the name HDFS and codec. So this kind of configuration is there. So here let me see the exact thing. Your agent sync, then type of HDFS, okay, and the name HDFS, and then later on codec you can provide. So the value would be gzip if you want to use the gunzip. So this answer would be for this would be gunzip. So file would be compressed in HDFS. So this kind of configuration you can do over here. So now let's move to the another topic on this same whatever we were discussing. So now we have discussed about source and sync. Let's move to the channel. Okay, so channel we have already configured, but let me go into the, this is your holding area, correct? Like you source read the data, it push into the channel. So now channel is the holding area where some data is kept in, and then from there sync will read it. So this is the holding area. So now from here the data returned to the sync. So but there are two type of channels. Okay, one is durable and another is non-durable channel. So what does durable channel, I would say non-durable channel first discuss it. So these are the memory channel. Non-durable means whenever, suppose this is running in your agent and something goes wrong, somehow this agent is down, crashed. So whatever returned to the channel will be gone, because it is available only in memory. And whatever, like this is Twitter is continuously feeding the source and source to the channel read from a sync read from the channels. Now this agent is down and you even bring it up, this data won't be available, this you all have already lost it. So that's the memory channel. So that is the every so where we should use this memory channel then, if that we will lose the data. So the most of the things where if you lose some logging data which is not that important, like you miss 2-3 tweets for analyzing, and because of channel down, even 1,000 tweets you miss in per day, in our day suppose, then it doesn't affect your analysis too much. Actually it would affect definitely, but it is not going to affect too much. So that is the place where you can use the memory channel. Why we use the memory channel? Even we are saying we are going to lose the data, but why we are going to use the memory channel? The reason being memory channel is very fast compared to the your durable channel. How come it's fast? Because everything it keep in memory and it reads very sync can easily read in the faster ways, because there is no disk read or something, so it can faster ways to read the data from the channel. So that's why memory channel is uh, accepted. Any failure results in a data loss and has much lower storage capacity. And another harm over here is whatever RAM is available is your capacity, or whatever the process has started with the memory is the my capacity area. So that is the another disadvantage of using the memory channel. So now let's move to the durable channel. So what durable channels? Whatever first source sends to the channel first stored into the your hard disk. Let's assume it on a hard disk, it's persistent. So if agent goes down for some time, still as soon as you make it available again, it can read the whatever events has been generated from the files, because that is already persisted, and then from bring it to the memory, and from there sync can read it. So that is the advantage over here using the durable disk. So durable channels flushes all the changes to the disk before acknowledging the receipt of the event to the sender. So source send the data to the channel, so first it persists it, then only acknowledge it whether I have received the data or not. These are considerably slower because this persists the data, so this is the slower process than using the non-durable memory channel. So it provides recoverability, obviously, which we have discussed in the event of system failure or Flume restarts you can do, so you can get it. So now question comes is which channel we should choose, on what basis. So it depends on the your failure scenario and your risk tolerance, how much risk, like missing the tweeters 1,000 tweets in a once in a while, that is not a big thing, then you can use the memory channel. Or regardless of what channel you choose, okay, so whether you use durable channel or non-durable channel, if your rate of data ingest, suppose this ingesting the data 100 per second events, and this consumer can read only 10 events per second. So what happens? Ingest from the source into the channel is greater than the rate of sync. So obviously this is greater than sync can write the data. It will exceed the channel capacity. The sometime whatever its file or whatever memory, some limit is there to store, correct? So it is keep increasing over here, and once the disk is full or your RAM is full, your Twitter agent is going to crash because there is no memory for space issue. So there it will throw a channel exceptions. So this channel exception needs to be handled by the source then, if that is the case. So you have to take care, like your sync should be kept fast enough to read the data from the channels. So to avoid this kind of problem, you will want to try and keep channel depth. This is called channel depth, how much you can store, or the number of events in the channel as low as possible. So you keep number of events in the channel as low as possible. Its reading should be the fast enough. because time spent in channel translates to the time delay before reaching to the final destination. So how much time, whatever time it's, suppose it's 10 event is generated 10.01.01 second and it reaches here, suppose 0103 seconds. So there is a 2 seconds delay while reaching the event. So it could increase slowly if depth is high and all this thing. So you may not get into the situation where once your sink fails behind, suppose this fails behind somehow, you can never catch up, because you can see the speed, if 10 events per second and this 100 events per second, you can never catch it if it is continuously running, because your speed is too low. So you should keep in mind this speed should also be the good enough to process the data. So your sync processor should be fast enough, whatever you have written, custom sync processor. So now we were talking about durable and non-durable. Let's move back to the again non-durable system matrix. So where to use this system matrix usually fall into this category, as few loss of data points is good enough. So system matrix you are getting it. So like performance matrix or any matrix you are catching it. So some data loss is okay. For instance, if your events represent a purchase on the websites, okay, some selling or something, then missing any single transaction is a big loss, correct? So you should use in such scenario the durable, which can persist. So we don't want to lose any single event in that case. So that time it should have used the durable channel. So how to configure this? So let's go over here. Okay, the type of channel. Okay, here you can see Twitter agent channels. Mem channel is the name of channel, and type here, so it has used memory type of channel. Okay, this is the memory channel, so it's a non-durable channel. It has been used over here. Okay, so now the again move to the another configuration. Before that, the default capacity of channel is 100 events. Change it with the, so you can change. So your channel capacity is 100 events. So 100 event it can contain at a time. Okay. So this is the another capacity 100 here configured. Sorry, this is the capacity. Here we have configured and increased the to the 10,000. So 10,000 events can be stored over here. This is the capacity. Okay, now this is the transaction capacity. This is a different point we will discuss later on. So now this is the your event could be big enough or small enough. It's depend on the log size. So while configuring, this is again a Java process. So this channel keeps everything in memory. So you have to take care XMX and XMS parameter as well, which assigns the memory to the channel when the process starts. So you have to take care of what XMX and what XMS you have defined for the event, and what is your capacity. If you can increase this capacity 10,000 to the 1 lakh suppose, then you need more memory, right? Then XMX should be increased accordingly. So it's based on your event size, how big is event, accordingly you have to set this XMX and XMS value. Now you may another configuration is the transaction capacity, correct? This we have configured over here. So this the maximum number of events which will part of single transaction. So 100 events would be part of the single transaction. So from here 100 events would be read and then would be committed, then it would be cleaned from the channel. So this is every 100 events would be the, so in the 10,000 events are there, so there would be 100 transactions for the 10,000 events. So this is the transaction capacity you can control. You may wish to increase with this higher value to decrease the overhead of the transaction wrapper. So your transaction should not, like, because as an example, let me clean it out here. Suppose you have 10,000 events. So there will be 100 transactions. Correct. Each transaction takes 10 seconds. Let's assume it's not a correct value, but let's assume 10 seconds. So that whole process goes to the 1000 seconds. Now you see, like, it's taking a lot of time. Why can't I increase to the 1000? So my event capacity, transaction capacity to the 1000, so it would become the only 10 transaction, and each transaction will, instead of 10 seconds, will take 12 seconds, let's say, because of event size. So overall process will again still finishes in 120 seconds. So this is the trade-off, how you decide it and kind of thing, because increasing the transaction capacity, in case of failure, anything goes down, like, sorry, not diagram, from channel to the sink, when goes, and suppose your failure goes, everything needs to be rolled back. So in this scenario, 1000 events needs to be rolled back. So this is the, again, this process would be slow, and it is has to be rolled back. And if you have 100, then this would be faster. So this is trade-off the failure situation. Based on this, you can configure it. So okay, so now this is regarding channel. Okay, let's see this again. Let me draw the diagram. This is source, channel, and this is sink. Okay, and this all three run in agent. So now there are threads, correct, which copies this data from here to here and from here to here. So there is a keep one configuration which is not done over here, keep alive. I don't think so it is there. Okay, it's not there, but what does that mean? Let's keep alive. The thread which writing data from source to the channel, okay, this channel data write source to the channel, will wait in case of channel is full. Suppose 10,000 is my depth, so already 10,000 events are in this channel, and sync is slow to read, so it has to wait, because it's reading 10 seconds per second. So, and it is pushing 100 events per second, so this thread has to wait. So how long this thread wait before getting timeout? It cannot infinitely waiting, because suppose this thread is not working, somehow the sync has crashed, and it is sources keep pushing the data into the channel, but how much time? And as soon as channel reaches 10,000, there is no consumers events remain in the channel. So, and it want to push it, so how much time this thread has to be blocked? Like, it has to be some configuration, correct? So you can configure it. So after that, this thread would be dropped, sorry, the whatever it has gone, this thread, this 100 event would be dropped, and suppose sync come back again, so this 100 events you have already lost it, but this thread is still alive and read the next 100 event and can push it. So this way, it's this configuration could help you out in case of sync goes down or sync lowers, and you don't want to wait indefinitely for reading, because if you wait more than some period, okay, let's say, if because of sync is down, you are waiting 10 minutes, and this thread is longer duration is waiting, okay, indefinitely waiting. So whatever events are being generated over here upstream, you can say, would be dropped here, so you will lose data over here. So like, rather than so you lose this 100 events and keep reading again, and kind of, this is the trade-off you have to configure accordingly, which is your preference. Like, if you want most of the event to be captured, so you can configure accordingly. This is trade-off. Again, setting this value to very high will be block the data flowing into your source. If you, again, the same thing is there, which may cause data a, backing up in an upstream agent. So it is being back up here. Eventually, as soon as, like, there is again some capacity, because this is again Java process, some maximum capacity, correct? Eventually this may result in events being dropped. Somehow the events will be dropped, so this has to be configured accordingly. Okay, so this is regarding memory channel capacity and kind of thing. A file channel is that stores events, okay, to the local file system of this channel. Okay, it is stores in the local file system of this channel. If this channel is a type of file, it should be used in case where the gap in your data flow is undesirable. Like, same thing which we have already discussed, like whenever you want to record the selling or kind of data points, so, or stock market transactions, stock market ticker value, this kind of stock market price, This kind of value you don't want to lose at time. In such case, you can use this kind of file type agent. Okay, so now let's move to the another topic. Okay, in inspect and transform events in the flight. Okay, so what that does mean, okay, which was not in your agenda, but let's finish it out over here. It's not a big topic. Inspect the event on the fly. Suppose this is your source channel and this is sink. Inside the agent, the event goes here. You want to change some content over here. Change the content. Okay, this is channel, this is source, this is sink. Or you want to also do something over here, some filtering or something. So this thing you can do in the using the interceptors. So these are called interceptors. Basic introduction we already had it. So there is one method in the interceptor is a Java class. Okay, so there is the inspect method, and this is the event. So event object. So you can do anything with this event in the middle before transferring to the channel. So like example, you want to add some timestamp value. Suppose it's not there, or want to update this timestamp value, or you want to add the host name or some another key value property you want to add the event. So what you can do it, you just introduce one interceptor in between and do this thing. So you can have multiple interceptors or single interceptors. You can have interceptors between source and channel or channel and sink in between. Wherever you want, you can do this. So whatever the order you define, like I1 is my first interceptor, then I2, and then I3. So this is comma separated value you will define to the like suppose my agent is name agent dot sources dot s1 is the name of the source interceptors. Okay, something, and I1 comma I2 comma I3, three configurations, three interceptors. So they would be executed in this order: I1, I2, and I3. And then there is a interceptor. So if you want to change the event on the fly. Now next is okay, so there are default interceptors are available as well with the Flume. So timestamp interceptor, as we were discussing, timestamp interceptor, what it does is actually add event timestamp to the event. So you can just I1 dot type configuration there, you can say timestamp. You don't have to do any implementation for this. Similarly, there are another host type of uh, what you say interceptors are there, so which add the host address. There's another static interceptors which will help you to add key value. So you can have key value. Like key value is example is whatever the name of the user ID, something you want to, and value is the, you can say Hadapeka. This kind of value you want to set it. So you can and later on you can use this value into the channel itself if you want to use it. So, and even you can have regular expression based interceptor. So you can filter out some events. You want to drop some events based on some regular expression, you can do using the interceptors. Okay, so now next let's move to the next topic, which is regarding channel selectors. Okay, so now what channel selector is actually, again let me draw the diagram. This is channel. Okay, so now it is not necessary you would have single channel in one agent. You could have multiple channel. Suppose channel 1, channel 2, and channel 3. Why multiple channel? Because based on this, channel 1 can send data to the another sink 1 based on some sink 2 or sink 3. Accordingly, sink can read the data from the channel. So based on the channel. So what is the advantage of using this channel selector? So channel selector comes before that. So this is your source which sends event to the channel selector, and based on something which kind of channel selectors you are using, based on that event will be sent to the channel. So suppose you are using replicating channel selector. Replicating channels, there are two type of channel selectors available. Actually, replicating channel selectors means every event, suppose my event name is e1, would be replicated on each channel, e1, e2 and sorry, e1 goes here, e1 also goes here, e1 also goes. So channel 1, channel 2, channel 3, all three channels the event could be replicated, and this is the default channel selector available. Until and unless you change this configuration value, this won't change, and it would, if you have multiple channel, it would copy to the all multiple channel. So now another, next, this is called replicating channel. Another is multiplexing channel selector. What does that mean? Can write a different channel depending on certain header information. So using the interceptor, you can add some header information like host value. Suppose host is from US based, host is India based, host is China based, something other country, different data centers, 3 data centers, correct? So based on this event, host data centers, I can redirect according to the particular channels. Like one channel is responsible for China event handling, another channel is for India event handling, and third one is US based event handling, this kind of event handling. So using the multiplexing selectors, channel selectors, we read the host header information, and in the header information we read the host information, and based on this, accordingly it would be targeted in which channel the data should go. You can write to a different channel depending on a certain header information. Hence interceptor logic and selectors. So combining, I would say, interceptors. Suppose I1, this is your channel selector. Both will decide the routing mechanism from source to the channel, in which channel it will go. So this is the uh, use of this different kind of channel selectors. So now another last topic is the sync processor. The sync processor is the mechanism by which you can create failover paths for your syncs or load balance events across multiple syncs from the channel. Okay, so you can use the sync processor in between, and according to, if based on your configuration, you can configure multiple sync or failover if some sync goes down, so in which sync the data should be transferred. This kind of configuration you can do it. So however, here we have seen sync 1, correct? So sync 1 can, I would have 3 Hadoop clusters, suppose, like one for India region, one for China region, another for US region. So my events based on host, it will generated US, China or India would be added using the interceptors, their host information or whatever based on decision is taken, and based on this it goes to the channel selector, and channel selector will responsible to send the event accordingly the China channel, the channel defined for China, channel defined for India, channel defined for US. And once data is there, the sync accordingly read the data like from the channel, and like particular sync will point to the particular channel, and that sync will move the data. Like let's say sync is for specific to China, so it reads for the China's information from the channel, and this goes to the cluster which is responsible for analyzing the data only for China country. So like selling a mobiles in China want to be analyzed based on some data, like from the data center website, because my website is global, but data center has different configuration accordingly. So some configuration, so we can get this information like China's data would go to the Hadoop cluster which is responsible for analyzing data for China. So I could have 3 Hadoop cluster in my data centers, and accordingly we can analyze data for different country. So this way we can configure the channel selectors and everything. So that's all about this Apache Flume configuration, which we have finished. So what I suggest here is, like, let me clean it out here. Some important things I wanted to mention here. Like, first, you subscribe this YouTube channel where this video is published. Reason being, because whenever we publish, you automatically get an email from the Google itself. New video has been uploaded. So rather than waiting for us to send you an email, or you visit hadoopexam.com regularly, so you can find it out as soon as the video is uploaded. Other than paid videos, we keep uploading different videos on different technology, so which will also you get update regarding that. So don't miss this subscribing the YouTube channel. Other than that, okay, little bit change on the Hadoop exam website. So you can see over here we have introduced main tab. Here we have CCD 410, CCA 410, Hadoop training. So here the training related HBase. Data science has been introduced for certification preparation. Then Amazon Web Service certification. We have introduced SAS certification for analytical purpose, and we are keep adding many things. Okay, so and these are internal tabs. You can keep visiting on this tab. You can continuously read this FAQ, and if you are looking for a job on the Hadoop sectors, please apply using this, or send resume to resume@hadoopexam.com. So these are some different changes we are keep doing on the website. So please keep visiting this website and subscribe to this would help you out. LinkedIn, you can send invitation so you can get updated. Facebook also, we have Twitter as well. And please subscribe to the YouTube channel, which is marked over here, so you can watch this video. So thanks for listening, and hope we will soon release more videos regarding this training. Thanks for listening.